I'm looking at this log file from Genivos. Um, Here's his post. Um, Looks to me like I looked at the video already, or look at it. We'll look at it together, but looks like it's flying pretty good. He says he's trying to check his D term cut hertz, and let's see what we've got. The first thing I have to do is I have to sync the video with the trace. Which is tricky because there's no sound in the video. What I did was I looked at the amp readout, and if we watch the video play back, let me just slow it down. There. The first moment when the amp readout goes up is probably when he throttles up, right? I mean, that sort of makes sense, doesn't it? So let's try doing start log here and see how that sort of lines up. Well, yeah, so now let's look at the throttle. Where's I'm going to need RC command. Hang on. And specifically, I'm going to want RC command throttle. So here's RC command throttle. So let's see at what moment the throttle comes off the peg. It's right there, right? We can see the motors immediately throttle up. And we can also see the moment when the armed display disappears from the screen. So that's going to be the moment when he throttles up. It's going to be something like that. That looks pretty close. Let's see how that looks. We could probably bump back just a smidge. Yeah, so I feel like we're pretty close. So that's an aspect of Blackbox that may be often overlooked in some of the tutorials, is syncing up like that. If you don't have the beat to work off of, it's a little tricky. So the first thing I'm going to do is I'm just going to look at the overall level of vibration and noise. And I'll do that by zooming out, as usual. Gyros look very good, look very clean, no complaints there. The other thing that Boris has suggested, and it's very good advice, as Boris's advice usually is that we also want to be looking at the motor traces, and that's something I've often overlooked. I've been sort of assuming that if the gyro traces look good, the motor traces probably look good. And what Boris specifically says to look for is what he calls Pac-Mans. And what he means by that is that if you look up here, we don't want to, you know how Pac-Man kind of looks like his mouth is opening and closing, right? We don't want to see these motor traces constantly sort of opening and closing, jumping up and down. And we can also see a characteristic pattern of maybe we could call them shark fins down here in the motor traces. These motor traces look pretty smooth. So again, that suggests that we have an adequate level of filtering. It's possible that we could be over-filtered and not know it, but I think you're more likely to be under-filtered than over-filtered. For most of us, we're starting from very high filter cutoffs and working our way down, and we're probably not overshooting. So let's just take a look at the playback and see we don't see a lot of Pac-Mans here. There's some shuddering in the motors, and that's just normal, but we don't see them just sort of violently opening and closing. So overall, it feels like the level of noise in this trace is good, and the level of filtering it's not excessive. I'm sorry, I meant the opposite. There is at least enough filtering. Perhaps there's too much, but there's at least enough. So then let's have a look now, and we'll just pick an axis again. Actually, I'll tell you what let's do next. Let's just take these out of here. And let's just, since we have a video, right? Oh my gosh, we have a video, go figure. Let's just watch the flight a little bit and see what we see. It'd be really nice to hear the motors here. But anyway. So it looks really good. I mean, the fact that we're even in a position where we might start to nitpick something flying this good really says a lot about how far we've come. It's a little hard to tell without your hands on the sticks how responsive and locked in the quad feels. So here we've got a punch out. Here we've got a punch out. Let's just back that up slightly. And I want you to notice on the punch out that the copter does not pitch forward or pitch backward, but it sort of maintains its attitude pretty consistently. Let me slow it down just a smidge. Watch the punch out and watch the horizon. There's a little bit of a pitch down, maybe. Let's watch the pitch stick and make sure that that's not actually commanded. Yeah, so there's a little bit of a pitch forward, just a tiny bit. It doesn't look like it was commanded. I'm not sure I would even complain about that. If that's the kind of thing that you're seeing and you want to try to deal with it, increasing pitch I is the answer. But oftentimes I find that I can get myself into a situation where pitch I is so high that it's hurting me the rest of the time. And there's this sort of trade-off that we make when we're tuning, where if we try and tune every single situation that we don't like, you can tune the extreme situations out and ruin your normal flight the other sort of 90% of the time. So I don't think I would worry about that. It looks pretty good on that punch out. I'm very, very sort of happy with that. There is a little bit of wobble on the roll axis here. Back up, back up. If you watch the left turn here, and again, I don't think it's really commanded much on the stick. The stick is pretty solid, and there's a little bit of wobble there on the roll axis. Now, my first instinct is that perhaps roll P could be higher because the wobble it's pretty soft. It doesn't have a sort of a hardness, a sort of a sort of a violent vibration like you would see with excess P. And so when I see those kind of soft wobbles, my first thought is that P might need to come up. So let's take a look at our roll PIDs and see what we see. And let's also get RC command up. Let me do this. I like to put RC command on the top because it's going to get covered up by this stuff. So it's hard to see the details if that's like the PID trace. So there's RC command sub roll, and let's put the gyro there too, because I like to compare the gyro with RC command. Gyro, where are you? There you are. Now we'll back up out of that turn and just watch it play back slowly. Here comes the turn. Now we can see the wobbling in the camera, and we can see the wobbling on the gyro trace. This is a great example of why I think it's important to have your flight video as well, because we've seen other gyro traces that kind of looked the same as that, and yet we didn't see a lot of wobbling in the camera. So this is a case where it seems like that might be something that might be worth looking at because we're seeing it in the camera. Boom, 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 back and forth. Now it's steady. So one thing I see here is that the P term, it does sort of look not too big. It's a little hard to get a sense of scale on these, but the P term is not very large, and the D term is in fact larger than the P term. So it feels to me in this situation like probably the P term could be raised, and we would get rid of some of that oscillation on the roll axis. Maybe I don't know. That's what it seems like. The D term looks like the magnitude is probably about right, except that the P term is too low. This D term could definitely be a little more filtered. Let's see if he says what the cut is at. Doesn't say. You know, you get down into these extremely low values like D term cut hertz equals 10, equals 8, equals even 6 I've heard about. Get it where it needs to be and look at how it flies. It feels really weird to get the number that low, but this could probably be a little more filtered even. I'll bet that Boris would say this should be much smoother. I'll tell you that. I notice right here that the back right motor is maxing out. In general, we probably don't want to see that too much. Granted, we're at a relatively high throttle, but we're not at full throttle. And anytime we're seeing a motor maxing out, we're going to get destabilization or limitation in performance. It's also interesting to me, if we look at the motor trace, none of the others' motors are maxing out. We're flying more or less straight, so why would just one motor max out? In other words, if we were flying straight and we had a positive I term causing us to pitch forward to fight some kind of a pitch back force, then we would see the back two motors spooling up roughly equally. If we've got a yaw force that we're trying to counteract, diagonal motors would spool up. And if we've got a roll force we're trying to counteract, then motors on the same side of the copter would spool up equally. But here we've got a situation where just one motor is maxing out. And it could be nothing, but it also could be that there's a problem with this motor. It could be like a bad bearing or a bent shaft or a bad prop or an ESC that's not calibrated right. So that stands out. Overall, I mean, the thing flies great. Don't get me wrong. I'm always looking for a little. There's a little bit more sort of wobbling on roll here. Watch the roll. Oh, I may not have gone back far enough. Let's watch it again. Here, watch. Maybe not. Maybe it looks like maybe that was commanded by the stick. I could be wrong. Great flip there. Ends sharply. Looks like your rates aren't super high. Uh, we could look at the graphs, but who cares? It looks great. I mean, that's what really matters, doesn't it? Notice that the relationship between your RC command and your gyro is fantastic. Look how the RC command comes back to the axis and the gyro snaps right back to the axis. They get to zero at about the same time. And what that means is that you as the pilot are going to feel like the copter is really locked in, because at the moment you center the stick and mean to end the move, boom, the move is ending, right? Likewise, similar thing on the beginning of the move. So that's great. Again, same thing here. Almost as soon as you're back to the axis, the gyro is back to the axis. That's got to feel really good as a pilot when you're flying it. You see, I don't know if you can see this, but there's just a little bit of sort of wobbliness on the roll axis. Boom, boom, boom. It's going back and forth. And I don't think the stick is doing that. So, yeah, it feels to me like that might be just a little more peaking on roll. Okay, so anyway, that's what I see. You got a front flip? Are there any front flips in here? Maybe. Is that a front flip? Hang on. Got a almost right. No, just a turn. This is a great tune and a great flying quad. Definitely remember whatever your current settings are before you change anything, because it's easy to keep trying to make it better, make it better, make it better, and 5 steps down the line, you've made it, 3 steps worse, and you forget where you were at the last time you actually liked it. So this looks really good. That's all.